Yeah.
All right. So, what's the rule for adding? So, how many places after here? And here? So, what did you round the answer to? 19.35. All right. Now, in the second one, we're multiplying. So 0.0256 times 23.60. I got decimal 60416. Did I do it right?
Yeah.
All right. So to round here, we need how many significant digits in the first one?
3.
How many in the fourth one?
4.
So I only want to round to 3 significant digits, so 0.604. Now, if you wanted to put the leading 0.604, that would be the same answer. Okay? Questions? Any issues with the first two?
No, but
All right.
third and fourth were lost.
Now, the scientific notation works the same way, which is why I put these up here, because we didn't do those yesterday. So 1.2 second EE 6 times 6.35 second EE negative 8. Now, when you get your answer, if those questions are in scientific notation, what do you think I'm going to the answer in on the quiz? Same thing. So make sure it's in scientific notation. So 7.62 times 10 to the negative second. Now, when you look at this, it's multiplying, so we're using what rule? Significant digits. So how many are here?
2.
2 significant digits. How many are here?
3.
So I want how many in my answer?
2.
So what are the first 2 significant digits?
2.6.
So 7.6 times 10 to the negative 2. Oops. Okay? So 3.56 second EE 12 divide 2.136 second EE 5, and you get 1.66 for quite some time. So I'll just write down several of them. Times 10 to the 7th, right? Now, again, when you look at what you have, you're dividing, so we're going by what rule? Significant digits. How many are here?
3.
And how many are here?
4.
So the least number is what?
3.
So I'm just going to keep those. Now, again, we talked about this yesterday. This should do what? Should round up to 1.67 times 10 to the 7th. But if you wrote 1.66 times 10 to the 7th, I am not going to mark it wrong. Questions? Yes? No? Okay? Everybody see how scientific notation works? It's not any different. The exponents do not factor in figuring out significant digits. All right? Can we talk homework?
Yeah.
Okay? All right, so number 1 should be 8, and for those of you who are absent, it's on the back side of the one you did. Okay? From Monday night. All right? 8, and last night was Monday night, Friday night, over the weekend. 18.3, you did it. I might need to work on that organizational skill then. There we go. Everybody else found theirs. So I don't have to repeat things 8 zillion times. All right, so number 1 should be 18.3. If you left 18.2, it's fine. Number 3, 20.41. Number 5, 548.68. Number 7, 23.0. If you left 22.9, that's fine. Number 9, 375.5. Or if you left 375.4, That's fine. Questions about any of those? 9, 375.5. 7 was 23.0, but if you left 22.9, it's fine. Any questions about how to get anything in the adding and subtracting? No?
No.
All right, number 11, 15. If you left 14, it's okay. Number 13, 1.2. 15 is 0.3. If you left 0.2, it's okay. Number 17, 150. And number 19, 110. Anything else? Questions? Things you don't know how to do? Yes, ma'am. Sure. I get to hear it fourth period too. Probably heard it first period too, but I had my earbuds in, so I didn't hear it. All right, 17. 271,000 times decimal 0031 divided by 2.36 squared. Now, did you get an answer of 150.83668 or something in that ballpark when you punched it in?
Yes.
Did you get that, Jola? Because if you didn't get that, we can't even talk significant digits. Yes? Okay. So, given that you're multiplying and dividing, all right, you're looking at your significant digits. So, how many significant digits did you have here?
3.
3, because 2, 7, and 1 are 3. All right, how many did you have here?
2.
And how many did you have here?
3.
Okay, so the least number was 2. So you want to keep the 1 and the 5. Okay, but if you had $150 and I reduced it to $15, would you be very happy? No. So you want to keep that in the same decimal place. So we want to keep the 0, but to make sure it stays only 2 significant digits, do we want to add the decimal? No. So we're just going to write 1, 5 and no decimal. Okay? Because if I put the decimal, what happens to that 0? Makes it significant. So we're going to leave the decimal off and just make it 150. Okay? All right, number 19. We have 2.86 divide decimal 013 times decimal 938 divide 1.9. All right, and so when we do that, we get 108 decimal 6105. So again, same rule. We're multiplying and dividing. How many significant digits here? How many here? Okay. How many here? And how many here? So the least number is 2. Okay. Are we okay with that? So when we go to find our answer, most people get here and they're like, okay, I got 108. 108 has how many significant digits? It has 3. So we need to round it in a way that it only has 2. The only way you can round 108 to only have 2 significant digits is to round that to 110. Now, if you ever have trouble with that and you cannot figure out how to round the number, you can always put it in scientific notation. Okay? So if you put the number in scientific notation, 1.08 times 10 to the second, round off 1.1 times 10 to the second, and you have 2 significant digits. So if you ever get stuck and you cannot figure out how to get the right number of significant digits, put it in scientific notation, and then you can round off to whatever you want to. That's an easy way to do it. Anything else on the homework that's bothering you? You need more practice with it because you're going to do a lab with it in a minute. So I'm going to hand back your lab papers from yesterday. Some of y'all got hundreds. There were not a ton of hundreds. I thought there might be a few more of those than there were. Take me a couple minutes to hand these back. Yeah.
Did you read it?
With the exception of lab reports, you will generally get papers back the very next day, unless I just don't remember handing back.
It's a shame.
He hasn't put in the only sheets that they had to do. He has 4 zeros. He just signed papers. I understand.
Sometimes reading the handwriting.
Hi, you know, like, that's my friend, but you have right to currency.
You can get yours, but yours is gonna be at the other end. All right. Oh, give me a second. That's you. Keep these out for a minute and I'll point out some things before you go to the counters to do something else with it and screw up not once but twice.
Are we done with the homework?
With what? Homework? You need more practice with the evens.
Oh, we're good.
Okay. Because I do not need to practice.
Like, I know what I'm talking It's gonna be
Hand that back. All right, if you look at your lab paper, all right, if it says SD minus 6, read your significant digits and I are wrong. Okay, you did not read it for the correct significant digits. Now, if you read a triple mean balance, what you're going to do today, okay? How many places behind the decimal should a triple mean balance read? You answer that at the bottom, okay? So not everybody read it 2 places behind the decimal. I don't know why you told me 2 places at the bottom and you only have 1 place at the top. I'm confused about that. Okay? If the piece of equipment reads to tenths, where does the guess have to be? Okay, so now look down at the bottom where the rulers are, where you have length and width. The rulers read to tenths. Where does the guess have to be? Hundredths place. That's where the biggest mistakes are made on this paper.
Did anybody get 100 on it?
Yes.
Oh, did you say
All right, so lengths and widths have to be 2 places behind the decimal also, because they work just like the triple beam balance. They have tenths, so you have to read to the hundredths. So there's 2 places behind the decimal when you read the ruler. And again, we're only reading centimeters today. Okay? Now, when you read your volume and your temperature, it read to the ones place, which almost, I don't think anybody got, no, there were a couple, but we got questions on the bottom. All right? So when you read the ones place, how many places behind the decimal were there? 1, because the guess was where? In the tenths place. All right? Now, if you did not write a unit on your answers, even though in bold it says include the correct units directly above the data table, There were some people who lost 7 points because it was -1 for each unit. Now, on today's lab sheet, I don't even know how many points you can lose for units, but it's fairly hefty. Okay? Please, please, please put a unit. If you write a number, it must have a unit on it.
Can we just use the same part to put district and stuff?
No, because I have enough equipment to have 2 people as a group. Do I have an even number to? No, I have one group of 2, or 3 rather, because Faith is not here.
Wait,
But I will only have one group of 3. 1.
but we're still in partners, right?
You're still not. Good.
Right? And what you working on?
All right.
I don't know.
I have to get out a couple more scales. I'm trying to get the scales at work. It's a library. You have no classwork grades. Sure. My group of 3 is established. Everybody else is a group of 2. Thank you for making that easy. Next time, they cannot be the group of 3, however. Okay, they were a group of 3 today. We will do another lab this week. They will not be the group of 3 next time. No,
Oh, we should.
Miss Walls.
won't work that way.
As of right now, you think this would be Friday or Monday?
Probably Monday.
Good.
I don't think we can make Monday. I don't think we can make Friday. All right. Let's talk ever so briefly about what you need to do so that you do not lose points for stupid stuff. Well, some people will anyways, because you won't listen and follow directions. All right. Yeah, because I don't think that one we had a couple days ago during fourth period counted. Several people told Ms. Wicker it was an intruder drill. I'm like, hey, I've never heard of that. And 2 or 3 classes were on the outside of the building with me, so we clearly botched that if that was an intruder drill. Ms. Bauer's class was all out there, and the annex people were outside, so we did not do well with an intruder drill.
So just like, don't open the door, what if there's somebody out there? I was like, okay.
Now,
No, try to open the door wide open.
now, if we look at the lab sheet, first of all, in the data table alone up here, there are 1, 2, 3, 4, 5, 6, 12 places for units, okay? So there's 12 points alone before you even get to the calculations section. So please do not forget your units. Now, on the back table beside Cheyenne, will you hold up one of each of those blocks? I'm fairly certain y'all can tell the difference between large block and small block, okay? So, if you can't, call me over there. I'll be glad to explain that to you, all right? Now, you're going to need the mass of each, the length, width, and height, and then the volume. No, and I do mean no, calculations go in this top block. The only thing that should be up there are the measurements with the units, okay? I should not see any multiplying up here, any division up here. I should only see the mass written, the length written, the width, the height, and the volume with a unit on each of those numbers. Now, at the bottom, where it shows calculations, this is where I should see your work. Now, if you don't show me the work, do I know how you got those numbers?
No.
No. I'm not going to pick up my calculator and punch in 27 people's, because Faith is not with us, volume numbers to see if they're correct. So I need to see if you put down that, let's just make up some numbers, that the length is 14.25, the width is 2.74, and the height is 4.15, and all of these say centimeters. I need to see that the volume equals length times width times height. I need to see 14.25 times 2.74 times 4.15. I need to see what the volume equals. And when you finish, it needs to have a unit on it. If it doesn't have that, then you lose points. Okay? You need, huh? I can. I'll just leave it laying here on the table because the screen will go blank. And then you have 2 questions to answer. It should not take very long to do this. Okay? Make sure the units are up there. No work is in the top. Work is shown here. And then answer the 2 questions. Everybody got it?
Yes.
Now, I'm going to need to find 1, 2, 3, 4, 5, 6, 7, 11 scales. I need 14, so I need 3 more scales. Somebody can work at the back table, probably one on each side. There's space to work on this side of the counter. And there's actually a rolling card at the back that a lot of times works well also. So, if you don't have a scale, come see me and we'll find one that works. Here's one scale that works.
All right, here we go.
Here's the scale. All right. How many more do I need? No, I don't. Who else needs a scale? Now, 1 group of 3. Who else is missing a scale? Do I need another scale or do I have enough for everybody? I got a scale for everybody?
We need to get.
Does everybody have a ruler or do I need more rulers? Y'all need a ruler? No, come get a ruler. Forget that sharing stuff. Does everybody have a ruler?
We need a ruler.
Who else needs a ruler? Anybody? How long group share a ruler? Come here.
No, I said no.
What?
She said no.
No.
Yeah, we already have a ruler.
Oh.
Just walk. No.
Oh, we don't need a ruler.
Yeah.
Okay. You want something
Millimeters. I see it behind. I see it, it's 50.
There we go.
I see it.
Yeah, that's it. Looks like. No. Oh, yeah.
Because the cat, there's 12 lines in this. No, centimeters. No, because that's not, it's a centimeter.
Yeah, it looks like. Almost.
Long wide. Yes.
Are we doing this in millimeters?
The big numbers are centimeters, the itty bitty lines are millimeters, so it is in centimeters.
So the big ones on this right here?
Those are centimeters.
Okay, right, like it's not.
Silly.
It's the right, you just follow.
Oh, yeah. So like nice, and I'm not touching. I guess it's the link. You look at someone and say,
Yes.
I put 14.9 for large. That looks 14, nothing to me. Yes, I feel like that. That is okay, so looking at it like this. This is the height. Height. I recommend it. Or you were looking at it.
This might sound odd.
Okay, so.
Can be, yes. Can be.
And what's the point?
No,
This, well,
yeah.
tell us if we're sure or not.
Huh?
Yeah, just for now, so the length is this, right? What's the height?
Wait, if you want us to. If you want us to, so we have to.
What do you do, this way? What do you do all three sides?
You should get the same thing.
Look, say you measure length in the middle, length in the middle.
Large.
So yeah, the height should be this, yeah.
I'm doing.
No, not as recently there. 6.
Alright, so. Is it 1.8?
The large one, the one
Yeah. I think they're both the same. Yes, they are. Oh, wait, does that mean they're the same race? Does that mean yes. No, but then this is.
Well, I think.
Wait. The width for that was gonna be 3. Hold up.
This one is
I'm talking about like after the
volume, we only need one behind it.
Only one?
Yeah. Because it says that on the third person or second person.
Yes.
Yep.
Go. Except for one thing that you just do. I mean, I thought we did. Alright, so we got.
We were doing
Alright,
it.
so.
Never mind, it is.
So when you calculate. Yeah. Yes, all right, now we just have to write out. Just say it was never nice. Times everything.
She asked.
And then.
No, zero.
Yeah, but I got 26.12 divided by 144.5. I got.
Yeah.
I got
Yeah, bring it here. Bring it here. It's too much background noise.
make sure that.
I thought that was too small.
For the density.
Because we have it.
Yeah. Look.
I just don't talk about it. It's a lot of them.
The density of the one is like 0.5.
Okay, yeah. We have our numbers.
Volume, small box is 14. Oh, the volume is the large box of the number is small. It's because the math. This is the large box. The smaller box.
I'm just going to try. Since I just. What is bigger? And their guys are like little stuff, so.
I can't be right or
Yeah, this height is
literally got the same thing.
And then you wrap it.
Oh my goodness.
I really gave you when I gave you 82.
I'm pretty sure these are still. There were some. Oh, wait, it says they were different. I was different. They were different.
I have less.
We have the height of 7.3. It's 3.8. Whoa. No, I use this.
There's parcels now.
Well, but for you to look at it, probably.
Yeah, because like I was trying to see my grade, you really wanted and it was like you had no classes. I was like, you don't have to have
Let's see.
Remember, because we had
Y'all be practicing this in there, go out your time. Yeah, practice what we did yesterday with it. I know what.
Thank you.
Doesn't matter when you make lists.
It doesn't?
No. What about these are relevant? It doesn't matter.
Are you sure?
No, I told you wrong, and I created a lab, I can mark on the answer. The only thing I would say I'm looking at is. This one's okay. This one I'm gonna tell you, these two sides. And you did this one, you did this, I think when you do this, I think it's like.
Oh, yeah.
Like different, all really different, it's all different here. That's the only thing I would say. Guys, it does not matter which one you put. Like a water side, this width and this height, it does not matter. When you came over here, you like, this was. But you can make anyone, this place, you made this rig.
it's the same thing that was
Okay, you just want to go back.
two numbers behind
And if it reads the text, yes,
volume. Only needs one.
if you're not reading a graduate.
I mean, not volume.
Take it out. Take it out.
It is, this is.
And like this big chunk right here.
Well, then I just-
Annabelle, what did you
Oh, yeah. But it says, one. Okay, you're looking at a ruler, right? You got the big numbers, and then you got the mini numbers in between. So we have many numbers in between that, so it has to be three. What? Yes, it has to be three. Come here.
Oh.
We did. If you look at this, you got the 17, but also, and then you got the mini ones in between the 17. And you got the spaces in between.
They were different because our estimates are not the most precise and the blocks are not.
The last one is your guess.
So you have three numbers after?
No, you need two. Three is.
That's all.
That's why I told you something. But you good, it's
Generates all around.
So basically, there's no right or wrong answer. As long as you have an
I'm so sorry. Yeah, I know some.
Yes, you know, we got rid of
Okay, Chris, these don't look too complicated, just write them around.
So that's, and then that's why I got points off
Right here.
Oh, that's a chair.
It's a stool chair.
Yeah. It's your chair.
Why are you doing that? Because we had.
That's why you don't notice.
I don't say the answer to that. Right on stage, you figure it out.
If it's 0.50, something down.
Now you got round to one. 5 is not round to 1. You took less than that.
Yeah.
Would you like a couple? You don't need it. What?
Yeah.
Go to the.
But I did all of the work in on the paper. This one is like, I don't have it. I did all of the work.
You guys.
So unless you want to say about the binder, you can go ahead. How were you thinking? I didn't answer any of them. I just said that I have more for
You were looking. What?
There's 3, 1, 3. Not actually, the decimal point on that.
Yeah.
So it'd be 3. See, I have a section. You would just have yeah. Yeah. Honestly, the zero is not. Okay, no, I saw that. Because I don't like crossing that. I mean, this was great multiple times. I forget. Literally. It doesn't look like a lot. I in my head, I was So I highlighted the first one though because I don't have one.
Always the student.
Never, because I made a chart multiple different ways of doing the problem. Yeah, like option 1 is 60, but option 2 like the ways that I read it. Like these just need a little bit more specific.
How many groups do I have still working? It looks like I've got like 3 or 4. 1, 2, 3, 4, maybe 5.
No, you're right.
Doing. You want this bed?
Oh,
I'm not looking at it.
good luck.
Which wants to do that.
Well, the bigger number, you do that. So that would be more dense than that.
I'm tired of looking at it.
Yeah.
It's hard.
I got you. I just I mean, right here, if a person is going to watch it, you
Yeah, it's one of the.
And so 40%, that's the grade of, we're not.
All right, we'll have all the last papers. Did I hear a no, I don't?
Oh, no, I was talking about.
Right, your shoes.
So I have them all. Is that a yes?
Yeah.
All right.
Yes.
All right, we're gonna do the quiz tomorrow based on time, and we'll move on to heat and temperature today. If we come in on a delay, we'll still do the quiz tomorrow. Okay? What?
Do you have an audio person?
Yeah, I think, probably do.
I think we need one more to complete that cabinet.
It's okay.
Oh, wait, no, you don't. Because that one goes there.
Probably so. It's okay.
We doing those now?
Yep, we're gonna talk about heat and temperature. Are these what? They're probably rolling. They might roll in tomorrow. It just depends. We might be able to finish it today. Yes, you will need calculators. You'll also need your orange charts today. Woo.
Yeah, you can do the alpha. So we can title this ink versus tip page. You typed it? No. You wrote it? Yes.
Wait. How come everyone you like let them
I promise you, I did not read it. I wrote
Heat and temperature are two words that we use again interchangeably in the English language. It's a lot like accuracy and precision. All right. So in science class, heat and temperature do not mean the same thing. They're not calculated the same way. They don't have the same units. We do not use the same piece of equipment to measure them. All right, we're going to start with temperature, because that's the one y'all are actually the most familiar with. Now, temperature is defined as a measure of the average kinetic energy of the particles in a sample of matter. All right, a measure of the average kinetic energy of the particles in a sample of matter. Now, I used a math word and a science word you should know from another science class.
Kinetic.
Kinetic energy means what?
Like stored.
Active.
You can say active, but I was going to use an easier word. Start with an M.
Moving.
Moving. Okay? Anytime we say kinetic energy in here, you just need to know it has motion. Okay? It's energy of motion. So, in order for an object to have a temperature, the particles have to be moving. Now, temperature is based on the average motion of the particles. That word average is what makes temperature and heat different, okay? Now, right there is the key to the definition. Now, everybody in here can tell me the units and the equipment that we use to find temperature at this point in your science career. So tell me the units that we use for temperature. Degrees Celsius, degrees Fahrenheit, and Kelvin. Now, we've already talked about this, so we all remember which one's the SI unit. Kelvin's your SI unit, in case anybody forgot before we take our test, which again will probably be on Monday. We might make Friday. We'll just have to see how timing goes. All right, we should all remember that the equipment to find a temperature is what? Thermometer. All right, in case you cannot spell it, it's spelled thermo and then meter. So anybody who's like me and you're spelling challenged, it's a thermometer. And I point this out just to compare and contrast heat. Because heat is not measured with a thermometer, and we do not use the heats Celsius, Fahrenheit, or Kelvin. Now, we are going to talk about the calculations to change between Celsius, Fahrenheit, and Kelvin. Now, this is one of the few times that I will let you write on your orange chart. So if you don't have it out, get it out. Okay? You're in an honors class, so you should be able to manually change between Celsius and Fahrenheit. And I will let you write the formula on your orange chart. I don't expect you to have it memorized, but I do expect you to be able to use it. If you turn to page 3, all right, on page 3 of your orange chart, there's a whole bunch of formulas. Okay? The second formula on the page, density was the first one. So for those of you who don't know the formula, it's there. The second formula on the page is K equals C plus 273. Now, this is the formula that allows you to change from, you guessed it, Kelvin to Celsius. Now, at the very bottom of that page, you may add a formula. You may add C equals 5/9 F minus 32. Okay? You should hopefully have seen it before, but if you haven't,
So then, wait, so Kelvin and Celsius is the top one.
Kelvin to Celsius is the top. That one you have to be able to use on the final exam because the state gave it to you. The one you're writing at the bottom, well, you have to be able to use on the final exam. No, but you're in an honors class.
Right.
So I'm expecting, being that you're in an honors class, you should be able to do this.
So Celsius and Fahrenheit.
Yes. So I'm expecting that you should be able to use the formula. I left my hand out. Okay? That you should be able to use the formula. Now, we'll do 1 or 2 just to make sure everybody's on the same page. I don't want anyone to be embarrassed. So we'll walk through 1 or 2. If you need extra help, just raise your hand and I'll do another one. Okay? Now, the top formula is the easiest one to use. It only has 2 variables.
Ms. Wright,
Yes, ma'am.
could I have Sarah in for just a moment?
Yes, you can. Thought you were going with your recruiter. Just a moment. How you going to Charlotte and back in a moment? All right. So suppose that you have 150 Kelvin.
Ms. Wright,
Yes.
she'll be leaving.
Okay.
Thank
You're
you.
welcome.
Guidance.
No problem. So if we have 150 Kelvin and we want to go to Celsius, which formula would allow us to do that? The first formula or the second formula? The first one. Okay? So K equals C plus 273. All right, nice and easy. We have Kelvin, so we're going to put it in for which letter? Okay. We need to find C. And you guys are all math wizards. You all know to do what? Subtract 273. It really is that easy. Subtract 273. Really. Be surprised how many times people actually do that on the test.
Do what?
It would be an answer choice, by the way. So 150 subtract 273 would be what? Negative 123?
Yeah.
All right. Now, sometimes people leave that as an answer. Does my answer have a unit on it?
No.
No. That's the variable. That's not the unit. So you need to write degrees Celsius on the answer. Now, in terms of your significant digits, nothing had a decimal place, so you just need to make sure your answer doesn't what? Have a decimal place. Yes, ma'am.
So could you use that to find K instead of C?
Yes, exactly. And if you were finding K, you'd just do what? You'd be adding, because the C and the K would, or the C and the 273 would be on the same side when you find the K. Okay? Any questions about the first formula? Okay. And this is the formula we will use most of the time. Most people do.
Screw up and actually put 272.
If you look at your orange chart, Annabelle, the formula is there. Anytime we use this formula, you can have the orange chart. The state's going to give it to you. I'm going to allow you to use it on everything, unless it's just not useful like yesterday's quiz. Okay? Everybody good? Yes, ma'am.
So we're gonna have to apply significant on this too.
Yes.
Bro, and everything in here. So is it
Yes.
everything in here? Everything?
Yes, for about 12 weeks.
So
Okay.
any equation will give us one.
Yes.
So basically we're practicing
Yes. Correct. Yes. Then you give birth, and I stop hounding you about significant digits. Correct. Yes, it's a very short gestation period. All right. So let's say this time that you have gone somewhere on vacation and it is 28 degrees Celsius and we want to know how to dress. Would we need jeans and a coat? Would we need shorts and a tank top? Suppose we do not have internet access.
Are we just practicing for the rest of the time?
No, we're gonna learn about heat yet. That's next. Yeah, we could stick our hand outside.
So this is practice for temperature.
This is practice for temperature. And we're gonna talk about heat. Okay, so if we have 28 degrees Celsius and we're changing to Fahrenheit, all right, what formula would we need? Correct. All right, so do we know how to do it?
Yes.
You want to give it a shot? All right, y'all try it. See what you come up with. Yeah. A lot of you can do it on your own.
Wait, I
With fractions. Do it the way I showed you. What do I always tell you to do first? Cross multiply.
Brothers, with brothers.
you have so much confidence.
Okay, I think I got it right.
Well, you can do it any way you want to. You have great math skills.
Well, we don't, so I don't know.
Then, Annabelle, if you sit there and go, I don't, put in your 28.
Yeah, that's where I got to.
They don't know how to do it.
Cross multiply. 28 times 9.
Big
Big number.
Yeah.
252 equals 5F minus 32. And I would bet everybody in here can go from there. Your fraction is gone. Okay? I told you. We suck at fractions. Cross multiply and get rid of it.
Okay, he gave me that extra point. And like 90, I was like, great.
So do we do the like basic math? We go 5 times F.
You can. You can either divide by the 5 or you can distribute the 5. You choose.
I got it.
Whichever one you like better. If Nikias saw divide by the 5, divide by the 5.
Okay, I got that.
Annabelle, if you saw distribute the 5, distribute the 5. Do it the way you saw it.
Okay, I said
Now, two geniuses over there with 82.4. You, my 82.4 people. Did you round for significant digits?
What's the secret?
only 2. Oh, we only
Oh, so it's just 82.
Y'all high fiving over there. Significant digits.
I didn't write it again.
Okay.
We don't have a decimal.
And 28, they're having significant digits.
So it's
So you got 82.4. So rounded to what? There you go. Now high five.
wait, why would
Okay,
you?
how about
You cross multiplied. I did it. You say you got 252, but you don't cross multiply 5.
Because that's 1 times 5. Yeah.
Wait, add it.
I had a student years ago that said stick a 1 up under there. Okay? So it's essentially 28 over 1. So 1 times 5.
Oh, I know. Okay, and in that you don't think about the significant digits.
You don't have to. That's not there. The only thing you ever worry about significant digits with is your starting data. What they give you to start with. The rest of it's a constant in the formula. So you don't worry about that. You only worry about the numbers that you started with. And you started with 2 in the 28. So that's all you worry about. So even when we get to where we look stuff up on the orange chart, you don't worry about anything on the orange chart. It's always based on what you started with in the original question. Okay?
Why is there 2 significant?
Because 28 only has how many numbers in it? 2. Okay?
So we take the significant number from 28.
From 28 and what you started with. Okay?
What you, what?
Your significant digits always come from the number you started with.
You was good when you was at.
All right. So when you go to solve, just to clarify, if you get here, you choose. Okay? Some people saw this as divide by 5. Move the 5 over there and divide. Annabelle saw it as do I distribute. You do what you feel comfortable with at this point. Okay? If you saw divide, then divide. If you were one of the distribute people, distribute. Don't tell your friend they're solving it wrong. Okay? Do what you saw in your head and go with that. All right? So did everybody get down to F equals 82.4 at this point? Okay. So did everybody hear me say significant digits are based on your starting data? It doesn't matter about the formula. So you had 2 significant digits there. We need 2 in our answer, so we round to 82. Okay? And then degrees Fahrenheit for our unit. Everybody good? Okay. Now, to finish the day, we're going to talk for a little bit about heat. We won't get it all finished. We'll have to finish it tomorrow. Okay? But heat. Heat is a measure of the sum total of all the kinetic energy of the particles in a sample of matter. Okay? It's a measure of the sum total of all the kinetic energy of the particles in a sample of matter. So, again, we're still talking about kinetic energy. So we're talking about motion. But this time, what math word did I use?
Sum.
I said sum. Okay? So, when we talk average, we're talking about adding everything up and dividing, right? But in sum, we're just adding everything up. So for those of you who work, Would you rather be paid on your total hours, on your average hours? Total. Okay? Because if you work a normal schedule of, let's say, 5 hours a night, who wants to be paid on 5 hours? Most of y'all be pissed. Okay? If you work 4 days a week at 5 hours, you want to be paid on 20 hours. You don't want to be paid on 5 hours. Okay? So, when we think about heat, as an example, let's say that we have
Right.
don't get excited. It's the only thing I can draw. Because this next one's just going to be butchered. I don't have a lot to work with here, so.
I can't draw that.
All right.
I'm gonna just look.
Got any guesses?
That's about.
Yeah, see, it's not terrible. All right. So we got a bathtub and we got a coffee cup. All right. So which would have more heat and why? Okay, why?
Because it's steaming.
It's smaller than it doesn't have as much space.
It's the same thing.
All right, tell me what the definition of heat is again. Sum total.
Oh, so the top.
Why is it the tub?
Is that more space? Like
It's
more,
not space.
more stuff?
There's more stuff in it. It's about size. Okay? The tub has more heat because there are more particles. Okay? Heat equals size or mass.
Wait. I have a question.
Hang on one second. The larger an object is, the more heat it will have. Okay?
What if I'm taking a cold bath though?
It will probably still have more heat than that hot coffee cup because there are so many more particles than the hot coffee cup. For example, a frozen lake will have much more heat than a hot swimming pool in the summertime because there are millions of more particles in a frozen lake than there are a swimming pool. Think about the massiveness of a lake versus a swimming pool. Okay?
So you said the larger
The larger the object, the greater the heat. Heat is about size. Okay? Temperature is about motion. So when Annabelle goes to basketball practice this afternoon and she starts running around, the particles in her body do what? They move and speed up. Her temperature will go up because her particles are moving faster. But heat is about size. Who will have more heat? Annabelle or Miss Wall? I will. Why will I have more heat? It doesn't matter.
It's because you.
I'm bigger than Annabelle is. I got Annabelle by 100 pounds. I have Annabelle by 100 pounds. I could sit in the gymnasium, do this, maybe for 5 minutes, and I guarantee you I'm going to have more heat than Annabelle has because I have Annabelle by 100 pounds. Okay? It doesn't matter. I have more particles than Annabelle has. Okay? My heat will be greater than Annabelle. Now, her temperature will be larger than mine because she will have more what? She will have more motion. Motion is about temperature. Heat is about size. How many fat people do you see in the wintertime who are wearing earmuffs, gloves, and snowsuits?
I was about to say, isn't there like a little like thing where it's just like fat people get like
Yes, they do.
Miss Love said that she
And when they lose weight, they freeze to death because they've had all this insulation all this time. And when they lose their insulation, they're cold. Exactly. Okay. Hefty sized people are not cold all the time. They're just not. Why do you think I'm not cold in here when you people come in and you're like, whoa, it's cold in here? It's not. Okay? I can say that with all honesty. Now, I have lost 30 pounds, so I'm a little chillier than usual. But still, I'm still not freezing to death most of the time. Now, what units do we use for heat? Now, we use calories. Now, calories, I'm only telling you simply because those are English units. What? Okay, those are English units. We're not going to use them very often in here. They do. This is heat. Okay, we're talking heat right now. Okay? Now, joules will be the unit that we use. And it's abbreviated with a J.
Joules are bad for you.
Not that kind of joule. Okay? Wrong kind over there.
No jewels anywhere.
And they're not pronounced jowls either. They're pronounced joules. Unfortunately, like the bad kind. Now, the equipment that we will use to do this, hopefully we will get to do this later this semester. I had to cut it in the fall because of the snowpocalypse. All right. We will use a calorimeter to measure heat. All right.
Why is it called
What?
Together 2 words on accident.
What'd you say, Chris?
Oh, why isn't it called a joule meter?
It's not. It's called a calorimeter because, again, in the United States, we use what units? A calorie. So it's named after the calorie.
Wait, so other countries with other nutrition facts,
They still call it a calorimeter.
So wait, so what is like, is just the SI unit?
Joules is the SI unit, yes. Okay? Joules is the SI unit. Okay? Now, because we don't have, oh, I need to stop. It's like 11:39. Y'all need to stop. 39?
Well, we can't, we're interested. We are interested. Thank you. We didn't know what.
Here's your homework. Practice for the quiz tomorrow. Put my calculators in the tub. I want to pay attention to my time. Remind me to finish heat tomorrow. To learn about the calculation of things. Yes, all of them. Easy on the calculators over there. Mine are old. Some of those are 20 plus years old. I know you are. I'm just being warning for the whole semester. Be careful with mine. All. 1 through 14. All. You need one?
Yeah.
Did I miss anybody else who didn't get one? All right, have a good rest of your day.
All of them are
All 1 through 14. You're all mixed up. Calculate. Study for the quiz.
all.